All right, so today we're going to go ahead and talk about calculating slope. Now, before we have been going ahead, plotting 2 points and going ahead and getting the slope using the idea of rise over run. Okay, so we've been plotting points, we've been counting up for our rise, and then looking left to right for our run. Okay, and if we were going to the right, it was positive. If we were going to left, it was negative. Okay, now the rise part of when we're calculating the slope, we were going up or down along the y-axis. So in essence, we're looking at the change in our y from one point to the other. That's just a fancy way of saying change. And then in the bottom, our run is along our x-axis over our change in our x. Where our y value change was on the top, our x value change is on the bottom. Right. Now, going ahead and graphing 2 points and counting is not the best way to go ahead and get slope. Because if our numbers were for some reason really far apart, that's a lot of counting to do, and it's a little bit too much work, and we don't want to go ahead and do that. So we're going to go ahead now and use a math formula for calculating slope. And it's going to look like this. Some of you have seen this before. We have y2, y subscript 2, minus y1, subscript 1, divided by x subscript 2, minus x subscript 1. In a nutshell, what this means, if I'm given 2 points, I'm going to subtract their y values, and then also subtract their x values in the same order as I subtract the y values. Let's look at a really quick example of how this is going to work. And we're going to keep the numbers really small. So if I have the point, let's say 0, 1, and 3, 0. Okay, we're going to use some intercepts. All right. It doesn't matter who you call y2 or y1, as long as the x matches. So if I say, okay, well, I'm going to call this one x1, y1, and I'm going to call this one x2, y2. If I have them labeled, I just go ahead and plug them into the formula. So I start off with y2, in this case y2 is 0, minus my y1. My y1 is 1. Now the bottom has to go in the exact same order. So in this case, my x2 is 3, and my x1 is 0. And all I do at this point is go ahead and do the math. So I have 0 minus 1, which is just negative 1, and 3 minus 0, which is just 3. So therefore, my slope is 1 over 3. If I were to go ahead and graph these, I should get the same result. I should have a negative slope, which means my line should be going down from left to right. And my slope should be 1/3. Let's look at that real quick. I'm going to draw a quick sketch graph. And just go ahead and make some hash marks here. Each one represents 1. And I have 0, 1, which means 0 on the x-axis, 1 on the y-axis. And 3, 0, okay, which is 3 on the x-axis and no movement on the y-axis. And if I were to go ahead and count these and do my rise first, my rise in this case, I only go up 1. My run is backwards, so it's negative. 1, 2, 3. And these are the exact same thing. Just one has the negative in the top, one has a negative in the bottom. They are still the same value. So we're going to go ahead and look at a couple examples, about 5 of them, and we're going to just use this formula right here, y2 minus 1, x2 over x1. Okay. So our first example here, I have 1, 1, and 2, 4. All right. And in this case, I'm going to call this one, it doesn't matter who is who. So in this case, I'm going to be a little weird. I'm going to call this one x1 and y1. And this one x2, y2. And no matter which order you put these in, you should get the same result. All right. So my y2 is 1 minus my y1, which is 4. Over, now remember, keep in the same order. So my x2 is 1. My x1 is 2. And in this case, I have 1 minus 4, which is negative 3. And 1 minus 2, which is negative 1. Now a negative over a negative give me a positive, so the negatives are going to cancel. And 3 over 1 is nothing but 3. All right. If I were to reverse this, I should get the same thing. So let's do that really quick. So in this case, if I switch them up, and now I'm going to say, okay, now this is going to be my x1, y1. This is going to be my x2, y2. And let's go ahead and do it again. So now I have 4 minus 1 over 2 minus 1, which is still 3 over 1, which is still positive 3. So no matter who you choose to be, the x1, y1, or the x2, y2, they should end up being the same thing. Example 2 here has a couple of negatives. Let's go ahead and look at it. I'm going to go ahead and just say, okay, this is x1, y1. This is x2, y2. And I'm just going to go ahead and do the math. Now I have to watch out. Now I have negatives in here, so I have to watch my signs. Okay. So y2 is negative 4. Minus y1, which is 3. My x2 is positive 4. And then I have a minus a negative 2. Okay, so the worst part of these is you have to remember the minus here and here is part of the formula. All right, the negative 2 is the value. So what's going to happen on the bottom is that's going to be 4, actually 4 plus 2 on the bottom. That's going to give me 6. Now on the top I have a negative minus 3, which is the same as adding a negative. So negative 4 minus 3 is negative 7. Right? And even though we got an ugly fraction, that's our slope, and that's all we were looking to go ahead and accomplish. Okay. Let's look at a few more. Now I totally encourage you guys to try these. Pause the video, try them, and then go ahead and watch the working out and see if you get the same answer. So these two are both going to be positive. So I have, make this x1, y1, x2, y2. I'm really not worrying about it. All right, so my y2 is 5. My y1 is 1. None of these numbers are negative. I don't have to worry about signs too much. x2 is 3. x1 is 3. This gives me 4 on the top. 3 minus 3 is 0. Okay, now we've talked about this. This is one of my special lines. And if I were to go ahead and plot it, it would be a line looks like this. All right. 0 in the denominator of any fraction makes that fraction undefined, which is exactly what it makes our slope. So the line of this type has a slope that is undefined because there's 0 in the denominator of a fraction. All right, let's go ahead and look at example 4 real quick. I'm going to go ahead and make this x2, y2, just for no reason, just because, and x1, y1. Okay, so my y2 is 3. My y2 is negative 2. Now remember, that's subtracting a negative 2. And then if I go ahead and do the same on the bottom, x2 is negative 7. minus a negative 9. So what's going to happen with both of these is both my signs are going to change here. So I actually have 3 plus 2 and negative 7 plus 9. Okay, 3 plus 2 is 5. Negative 7 plus 9 is 2. And so my slope here is 5 over 2. One more example for you, example 5. All right. So here, I'm not going to get crazy. X1, Y1, X2, Y2. Remember, it doesn't matter your order. You get to pick. Y2 is 5. I'm subtracting Y1, which is also 5. Divided by X2 is 5. And X1 is a negative 1, which means I minus a negative 1. Which means I have 5 minus 5 over 5 plus 1. 5 minus 5 is 0. 5 plus 1 is 6. And this one I have the 0 on the top of my fraction. And just like regular fractions, anything that has a 0 in the numerator and a number in the denominator is nothing but 0. This is a line that's going to go from left to right. Okay, so this slope is 0. So please go ahead, practice these. Also go ahead and work on the problems I gave you, and I will see you in the next video.